In the name of Allah, the Compassionate and the Merciful. Hello guys. In this video, I'm going to show you the concrete section ductility ratio optimization in C programming. As you see, we have an rectangular concrete section with different layers of steel rebar, as you see, and concrete stress is defined by witness stress block, and relation between strain and stress of steel rebar is defined with this formula, and we are going to have an moment curvature analysis. After analysis, we going to have an phi u and phi y. Phi u means ultimate curvature, phi y is curvature which is first yield appears. So the ratio between this is called ductility ratio, and as you see, each layer has a different distance, and actually in this example we have 6 layers of rebar, and we're going to have an optimization that which rebar is going to have an our target ductility ratio. And let's see, in this input file you see different rebar areas with distance of each layer, as you see, and actually we have 310 different sections steel rebar, and it is sorted. It is very important. It is sorted from minimum to maximum. It means that all rebars at the first row of Excel input is the minimum one, okay, and then it goes to maximum. So our programming is check each of these layers and for its input data to check the moment curvature and then the ductility ratio, and if it is our optimum criteria, and then the analysis is going to be finished and shows our best section for our optimum ductility ratio. And other input files is for defining the moment curvature analysis is actual force which is applied in the center of the rectangular concrete section, width of section, height of section, minimum ductility ratio as a lower bound of our optimization criteria constraint, and upper bound and or maximum value for our ductility ratio, and FSC, it means that the ultimate concrete section capacity. This value is ultimate concrete strain, and this value is yield stress of steel rebar. This value is ultimate value of steel rebar. This value is modulo of elasticity, and this value is strain at the first of strain hardening, and this value is ultimate strain of the steel rebar, and this value is number of iterations for our nonlinear analysis, and this value is a tolerance of converge of our analysis. And as you see, at the first input of each 6 layers input data comes to our modeling, and then moment curvature of this analysis is going to be calculated. After that the ductility ratio as a phi u divided to phi y is going to be calculated. Then it is checked between the lower bound or upper bound of our criteria of constraint for our optimization. If it is okay, then the analysis finished. If it is not okay, it checks the other section. Okay, but it is very important that we must sort our all three bars to minimum to maximum. You see that it is 3000, and it is increased by each layer because in each section the area rebars is increased. So let's see the C programming language of our modeling. As you see, at the first we defined the criteria of the concrete section as a deep width, height of and actual forces, stress strain of concrete and steel. And in input data 2 we're going to import rebar areas and distance of each layers. And if we want to have an Excel output, you see that after analysis we can export it to Excel or even in text file. And let's see in here, in analysis function, all analysis comes data comes from here, and then it checks for our criteria. As you see, all data comes from here, and in here moment curvature is calculated, and then in here it checks for our lower bound and upper bound, and if it is okay, it gets the okay solution and optimum solution, so the analysis is going to be finished. And let's see the exe file, which is round. You see that all data is imported in here from CSV Excel file. And let's see the analysis report. You see that in section 9 we have an optimum section for section ductility ratio, and you see that this rebar areas and distance is the optimum values for our analysis solution. And actually it shows that the section number 9 is the optimum section for getting the best results of these values. Thanks a lot, guys. Bye.